Think about the last time you stood outside on a clear night and looked up. You saw stars, hundreds of them on a good night, thousands if you were far from city lights. And if you are anything like me, a thought crept in, a thought that is almost impossible to suppress. Are any of those lights looking back? Is there something out there, some mind, some civilization, scanning the darkness and wondering the same thing about us? It is one of the oldest and most persistent questions in all of science. And what I want to share with you today is that the answer, when you follow the physics all the way through, is far stranger and more unsettling than most people ever consider. Not because the universe is empty, but because of what space and time actually are. We tend to imagine the cosmos the way we imagine a city at night, a vast, dark landscape studded with bright points of light, all of it sitting still, all of it accessible in principle, if only you had a fast enough car. That picture feels right. It matches everything our senses tell us. But our senses, as the physics makes overwhelmingly clear, are profoundly unreliable guides to the true nature of the universe. Space is not a static backdrop. It is not an empty container sitting quietly while matter moves around inside it. Space itself is a dynamic, stretching, expanding entity. And that single fact that space expands changes everything about what it means to search for someone across it. The expansion was discovered in the late 1920s when astronomers noticed something deeply peculiar about the light arriving from distant galaxies. The light was stretched. Every wavelength had been pulled longer, shifted toward the red end of the spectrum. And the farther away the galaxy, the more the light was stretched. This is not the kind of redshift you get from a fire engine racing away from you, where the source is moving through a fixed space. This is something more fundamental. The galaxies are not flying through space away from us. The space between us and those galaxies is itself growing. Every moment that passes, the fabric of space acquires more volume, more distance, more of itself. And that changes the calculation about contact in a way that is almost viscerally difficult to absorb. Here is how to make it concrete. Imagine you are an ant and you need to cross a rubber band. The rubber band is 1 foot long when you start walking. You walk at a perfectly steady pace. But as you walk, someone is stretching the rubber band. If they stretch it slowly, you still make progress. You still get to the other side eventually because the stretching cannot outpace your steady steps. But now imagine the stretching accelerates. Imagine the person pulling the rubber band apart gets faster and faster the more it stretches. At some point, the far end of the rubber band is receding faster than you can possibly walk. Not because you slowed down, because the substrate you are walking on is being pulled apart faster than any motion through it can compensate. That is precisely the situation facing any signal, any beam of light, any radio wave, any hypothetical spacecraft trying to cross the cosmos. There is a distance, a threshold, beyond which the expansion of space carries regions of the universe away from us faster than light itself can travel. That boundary is called the cosmic horizon, or more precisely, the Hubble horizon, and it sits roughly 46 billion light years away in every direction. Everything beyond that boundary is, for all physical purposes, permanently unreachable and permanently invisible. No signal from those regions will ever arrive here. No signal from here will ever arrive there, not because anything is moving faster than light through space, which special relativity forbids, but because the space itself is stretching, and there is no law of physics that caps the rate at which space can create new distance between 2 points. Now here is where it gets even more striking. That 46 billion light-year figure is not a fixed wall. It is not sitting still while we wait. The universe is not just expanding. Based on extraordinarily precise observations of distant supernovae, of the cosmic microwave background radiation, of the large-scale structure of galaxies, we know that the expansion of the universe is accelerating. Something which physicists call dark energy is pushing space apart at an ever-increasing rate. And that means the cosmic horizon is effectively shrinking relative to the amount of observable universe we can influence or be influenced by. Galaxies that are currently just barely within our cosmic horizon will one day be carried beyond it. The universe visible to us from this vantage point in space and time is, in the long run, getting smaller, not larger. Think about what that means for a civilization, any civilization. trying to announce itself to the cosmos. The signal they send out, a radio wave, a laser pulse, a carefully encoded mathematical pattern in the microwave spectrum, leaves their world and travels outward at the speed of light. For nearby regions within our local cosmological neighborhood, that signal makes progress. It crosses real distance. It arrives. But for civilizations beyond a certain remove, the signal is running on that accelerating rubber band. With each passing cosmic second, there is more space ahead of the signal than behind it. The signal is not gaining ground, it is losing it. And the situation is compounded by something even more fundamental about the nature of light itself. When light travels across expanding space, it does not arrive with the same energy it left with. It arrives redshifted, its wavelength stretched by the very expansion it traveled through. A signal sent from a civilization 10 billion light years away does not arrive as a crisp, identifiable transmission. It arrives as a whisper. Its frequency has been pulled down, its energy diluted by the expansion that unfolded during its journey. The more distant the source, the more the signal has been degraded by the geometry of the cosmos it crossed. There is no amplification that compensates for this. It is written into the structure of spacetime itself. Now layer onto this another piece of physics that rarely gets discussed in the context of the search for life. The universe has an age. It is approximately 13.8 billion years old, measured back to the period when the first atoms formed and the cosmos became transparent to light. That is the wall behind us in time, the farthest back any electromagnetic signal can have originated and still be traveling toward us today. The cosmic microwave background radiation, the faint afterglow of the early universe, is the oldest light we can ever detect, the last scattering surface, the edge of our observable past. And this finite age of the universe means that even in the absence of any expansion, there is a finite sphere of space from which signals could have reached us by now. Combine the finite age of the universe with the accelerating expansion of space, and you get a picture that is genuinely humbling. The region of the cosmos from which we could ever receive a signal and to which we could ever send one is not the whole universe. It is a bubble, vast by any human standard, but finite, bounded, and in terms of what the universe might actually contain, almost certainly a tiny fraction of what exists. The universe beyond our cosmic horizon is not hypothetical. It is real. The laws of physics operating there are, as far as we can tell, identical to the laws operating here. Stars form there. Galaxies cluster there. And if life arises through the same physical and chemical processes that gave rise to it here, then there are almost certainly civilizations out there far beyond our horizon who are just as alone, just as bounded, just as unable to reach across the full extent of the cosmos as we are. There's a term cosmologists use for the region of space we can in principle observe and interact with. They call it the observable universe. That word observable carries enormous weight. It does not mean the universe we have observed. It means the universe we could observe given perfect instruments and infinite patience. And even that region, everything within roughly 46 billion light years in every direction, is only a portion of the full universe. Depending on which cosmological model you find most compelling, the full universe may be hundreds of times larger than the observable portion, or it may be effectively infinite. But here's the thing. It does not matter how large the full universe is if physics prevents any information from traversing the distance between its parts. The universe could be infinite, could be populated from end to end with civilizations broadcasting their existence into space, and we would still be isolated, not by choice, not by failure of technology, but by the geometry of space-time itself. And we have not even addressed the most immediate layer of the problem, the one that operates not on cosmological scales, but on the more modest scale of our own galaxy. Even within the Milky Way, a structure roughly 100,000 light years across, the distances are staggering. A radio signal sent from Earth today, traveling at the speed of light, would take 100,000 years to cross the galaxy from one side to the other. Any civilization that sent a signal our direction from even a few thousand light years away sent it before agriculture existed on Earth. Any reply we send today will arrive at its destination thousands of years from now. The conversation is not slow in the way that a delayed email is slow. The conversation spans civilizations. It spans the rise and fall of empires, the evolution of species, the drift of continents. The communicators at either end of such an exchange are separated not just by space, but by the full weight of geological time. And the galaxy is a moving, changing place. Stars migrate in their orbits around the galactic center. In the time it takes light to cross from one arm of the Milky Way to another, the stars in those arms will have drifted significantly from where they were when the signal was sent. Aiming a signal at a star 10,000 light years away requires knowing where that star will be 10,000 years from now. And stars do not orbit as predictably as planets. They wander. They interact gravitationally with neighboring stars, with giant molecular clouds, with the distributed dark matter halo that pervades the galaxy. Targeting, even in principle, is not the simple geometric exercise it might appear. There is also the question of what medium a signal must travel through to cross galactic space. The interstellar medium is not empty. It is threaded with charged particles, magnetic fields, clouds of gas, and dust. These do not block radio waves entirely, but they absorb and scatter them. Different frequencies are affected differently. A signal optimized for travel through clear space arrives at the other end, having been filtered by the interstellar medium in ways that depend on the precise path it took, the density of clouds it passed through, the orientation of magnetic fields it encountered. Reconstructing a deliberate signal from that kind of channel noise is a profound engineering challenge, even assuming the signal was clearly structured and intentionally aimed at us. And now we have to ask the question that has quietly been there all along. What if some civilization is not broadcasting intentionally? What if the signature of their existence, their industrial output, their energy use, their restructuring of their planetary environment leaks into space without any deliberate attempt at communication? This is actually how we have been detectable, to the extent that we are detectable at all. Our radio and television broadcasts have been leaking into space since roughly the middle of the 20th century. The wavefront of that leakage is now about 80 light years across, an expanding sphere of modulated radio waves carrying the imprint of a technological civilization. Any civilization within about 40 light years of us with the right instruments could, in principle, detect that leakage. But consider the signal strength. The radio transmissions from Earth, even the powerful ones, have been dispersed over an ever-growing sphere of space. By the time that signal reaches even the nearest star, roughly 4 light years away, it is spread over such an enormous surface area that its power per unit area is extraordinarily faint. Detecting it would require an antenna of truly vast size, far larger than anything we have built, and the signal would be buried in the thermal noise of the universe itself. Our leakage is not a beacon. It is a barely perceptible tremor in the electromagnetic background, and the civilizations most likely to detect it are the ones closest to us, the ones for whom the signal has not yet been diluted by too many light years of travel. All of this converges on a picture that is both scientifically precise and philosophically profound. We are not simply small. We are not simply far apart. We are separated by the active, dynamic physics of a universe that is expanding faster and faster, that imposes hard limits on the reach of any signal, that dilutes and degrades information across cosmic distances, that demands a patience measured in geological time for even local galactic communication. The isolation of any civilization in this universe is not an accident or a failure. It is a direct consequence of the physical laws that govern the cosmos, laws that were set at the moment the universe began and have been playing out ever since with mathematical precision. When you stand outside again tonight and look up at those stars, you are not seeing the universe as it is now. You are seeing a superposition of moments in the past, each star a different point in history. Some of those points thousands or millions of years removed from the present. You are looking at light that left its source before you were born, before your civilization existed, before our species walked the earth. That light, those signals, those potential messages from across the cosmos carry within them the physics of their journey. They carry the imprint of all the space they crossed, all the time they traveled, all the expansion that stretched them on their way. And somewhere, almost certainly, there is a mind looking out from a world we will never see, at a sky whose light is already ancient by the time it reaches their eyes, wondering the same things we wonder, bounded by the same cosmic horizon, separated from us not by indifference, not by silence, but by the fabric of space and time itself, stretched beyond any possible crossing.